Let us continue the previous lecture on periodic function. What I have written? I have written the periodic function is like this. F of t is equal to t in the interval 0 less than or equal to t less than or equal to 1. It is equal to 3 in the interval 1 less than t less than or equal to 2. This is the problem, whatever it is given. Now, observe, in the interval 0 to 1, what is the value of f of t? T. So, therefore, here 1 whole over 1 minus e to the power minus 2s into integral 0 to 1 e to the power minus t. Observe the point here, observe the integral. In the interval 0 to 1, you ask the question, what is ft? In the interval 0 to 1, what is ft? In the interval 0 to 1, ft is t. So, therefore, it is t dt. Next, in the interval 1 to 2, e to the power minus st, in the interval 1 to 2, e to the power minus st into ft. That means you put up the question, in the interval 1 to 2, what is ft? In the interval 1 to 2, what is my f of t? F of t is 3dt. Okay, let us integrate this. If I integrate, the problem is finished. Right? Now, so therefore this is 1 by 1 minus e to the power minus 2s into, now observe, this is first function, this is second function. Let us apply Bernoulli's rule. What states Bernoulli's rule? First function t into integral of e to the power minus st, e to the power minus st divided by number behind t, that is minus s. Why? Because dt is there. Because dt is there. Integral of e to the power minus st is e to the power minus st divided by number behind t minus s. Next, minus. Observe, I will tell you in a more simple way. Right? First function t. Integral of second. Integral of e to the power minus st, e to the power minus st divided by number behind t minus s. Minus. Differentiate the first bracket 1. Integrate the second bracket e to the power minus st divided by number behind t minus s again into minus s. Right? This is what I am having. Plus differentiation, differentiate the first bracket 1, 0. Right? That is enough. But still for the sake of procedure I am continuing. Always you are differentiating the first bracket. Differentiation of 1, 0. Integrate the second bracket e to the power minus st divided by number behind t minus s. 2 minus s here, write down, it is plus s. So this is what I am having. I repeat. How do you apply Bernoulli's rule? First function t. Why this is first function? Because if you go on differentiating t, first differentiation of t 1, next differentiation of 1 0. Therefore I have to choose this as first function t into integral of second, integral of e to the power minus st, e to the power minus st divided by number behind t minus s. First into, always first we are writing first into integral of second. When once you write this, is to bother bit rare, mundadella easy. First into integral of second minus differentiate the first bracket, write it here. Integrate the second bracket, write it here. Again differentiate this bracket, right here. Integrate this bracket, right here. Again differentiate this bracket, right? Integrate this bracket, right? That's all. No need to remember the formula. Remember everything in terms of sentences. So now, observe. So 1 whole over 1 minus e to the power minus 2s. Integral 0 to 1. This I have integrated. So how I have carried integration? With respect to t, because dt is there. So since dt is there, you have to substitute t is equal to 0, t is equal to 1. So I shall write t is equal to 0, t is equal to 1. Now here, second bracket plus 3 into integral of e to the power minus st, e to the power minus st divided by number behind t minus s. Limits t is equal to 1, t is equal to 2. So it is very simple now. 1 whole over 1 minus e to the power minus 2s into. Now how I am, this is already 0, right? This is already 0. Now put t is equal to 1 once. If I put t is equal to 1 into e to the power minus s by minus s. Next 3 minus signs, that is minus e to the power minus s into t, 1, 3 minus by s square, right? This is 0 over. So minus. Now put t is equal to 0. If you put t is equal to 0, 0 into this 0. Next put t is equal to 3 minus sign, right? Minus. Put t is equal to 0, that is 0. Next 3 minus signs, that is minus. Put t is equal to 0. When I put t is equal to 0, e to the power minus 0, 1. So this is about this one, right? Next, what about this? This is plus 3 into, right? Put t is equal to 2, t is equal to 2, e 3 by minus s, let us take it outside. Put t is equal to 2, e to the power minus 2s. Put t is equal to 1 minus e to the power minus s. This is what you are having. So this is about periodic function. Let us take one more problem regarding the periodic function, right?
Sir, there we have a square. 1 by s square.
Okay, small mistakes may be there. Okay. So let us take one more problem. We'll continue on periodic function. Suppose it is given that f of t, right, it is equal to e into sine omega t in the interval 0 less than or equal to t less than or equal to pi by omega. It is equal to 0 in the interval pi by omega less than or equal to t less than t less than or equal to 2 pi by omega. And it is said that f of t plus 2 pi by omega is equal to f of t. You may say this is a periodic function with period 2 pi by omega. In terms of sentences, you may say it is a periodic function with period 2 pi by omega. Or so what this indicates, period is 2 pi by omega. Or in terms of sentences, you may say it is a periodic function with period 2 pi by omega. So now I have to find L. So what is the question? Find Laplace transform of this ft with period capital T is equal to 2 pi by omega. So now first let us write the formula. What is the formula? For solution, let us start like this. L of ft is equal to 1 whole over 1 minus e to the power minus capital S into t 0 to capital T e to the power minus st f of t dt. Note the important point, difference between capital T and small t. This is capital T, this is capital T, this is small t. So to this capital T, I am substituting 2 pi by omega. So substitute capital T is equal to 2 pi by omega. Then what happens? 1 whole over 1 minus e to the power minus s into capital T is 2 pi by omega integral 0 to capital T. What is capital T? 2 pi by omega e to the power minus st into f of t dt. So therefore this is 1 whole over 1 minus e to the power minus 2 pi s by omega into, now 0 to 2 pi by omega is there. Observe, 0 to 2 pi by omega. It should be broken as 0 to pi by omega one part. Observe, integral 0 to pi by omega. Next another part is pi by omega to 2 pi by omega. Pi by omega to 2 pi by omega. In this way it should be divided. So integrand, let us write integrand. E to the power minus st, right? F of t in the interval, okay, I will take one more step. E to the power minus st f of t dt. Next, e to the power minus st f of t dt. Right? Now, sir, in the interval pi by omega to 2 pi by omega, what is f of t? 0. in the interval pi by omega to 2 pi by omega, f of t is 0. So if I substitute f of t is equal to 0, this definitely becomes 0. Now in the interval 0 to pi by omega, what is f of t? In the interval pi by 0 to pi by omega, f of t is e sin omega t. So here for this f of t, I am substituting e sin omega t. So this is equal to 1 whole over 1 minus e to the power minus 2 pi s by omega into integral 0 to pi by omega, right, e to the power minus st. In the interval 0 to pi by omega, I have already shown you what is f of t. Capital E, it is a constant, into sin omega t dt, right, plus this is 0 because f of t in the interval pi by omega to 2 pi by omega, f t value is 0, so therefore simply I will write 0 here, right? You got the point? Why it has become 0? Because f of t in the interval pi by omega to 2 pi omega, it is 0. Now just we have to integrate this, right? Now how to integrate? Observe, this is equal to 1 whole over 1 minus e to the power 2 pi s by omega into, now capital E, take it outside, so here I will write capital E. What is the form? It is just like integral of e to the power ax. E I have taken outside. Sin bx plus c dx is equal to, what is the formula? E to the power ax by ax squared plus b squared into a sin bx minus b cos bx. This is the formula. This is similar to this. Now if I compare, what is x? X is equal to t. So here in this RHS, here in this star, in star, right, in star, substitute for this x is equal to t. Fine. What is a? A is equal to minus s. Compare, very important, a is equal to minus s, x, a, it is equal to minus s, x is equal to t, right. Next, e I have taken outside, sin omega t, sin bx, so b, observe, b is equal to omega, I am showing it by arrow mark. Omega is, b is equal to omega, not omega is equal to b, this b is equal to omega. A, it is equal to minus s. X, it is equal to t. B, it is equal to omega. All these things we have to substitute. So if I substitute, what happens? Capital E by 1 minus e to the power minus 2 pi s by omega, right, into, in this RHS let us substitute. This is the answer. Here I have to substitute e to the power a. What is a? Minus s, x, what is x? T divided by a square, what is a square? Minus s whole square, b square is omega square into, right, a, again a is minus s, sin b is omega, x, t minus b omega cos b omega, x value t, right. Now what are the limits? 0 to pi by omega. How I have carried integration? Dt with respect to t. So therefore t is equal to 0, lower limit, t is equal to pi by omega. So this becomes, right, this becomes equal to capital E divided by 1 minus e to the power minus 2 pi s by omega into, now t is equal to pi by omega e to the power minus s into pi by omega, s into pi by omega divided by s square plus omega square into minus s into sine omega into pi by omega, omega into pi by omega sine pi value is 0 minus omega into cos omega into t pi by omega, omega cancels, cos pi minus 1 minus, now put t is equal to 0, e to the power minus s0 minus 1 divided by s square plus omega square into t is equal to 0. When I put t is equal to 0, sin omega 0, 0 into this 0 minus omega into t is equal to 0 cos omega 0 1, right? So this is what you are having. Here note the point, omega cancels, sin pi, what is the value of sin pi? This becomes 0. Omega cancels, cos pi, what is the value of cos pi? This becomes minus 1 into minus omega. So that you simple, that everything is almost over. Okay, so okay, let us stop at this point, right?